Hi, I'm Paul Epps. We're doing Leetcode, must-know interview questions. Today's challenge, Jump Game 2. Uh, Leetcode rates this as a medium problem. I still think it's a hard problem, although the last one, the last challenge that we did was Jump Game, and if if you've done Jump Game, then actually this is a pretty easy problem. If you haven't done Jump Game, then again, I thought Jump Game was hard, and I think this would be hard. This is usually the way that I've seen this problem before. Is Jump Game? The question was, well, let's read what we're supposed to do here. You are given a zero-indexed array of integers, nums, of length n. You are initially positioned at nums 0. Each element, nums, at index I represents the maximum length of a forward jump from index I. In other words, if you are at nums I, you can jump to any nums I plus j. Well, okay, I mean, what it means is, for example, if you start here at example 1, if you start at nums 0, you can jump up to what do they call it? Well, up to a length of 2. So you could jump to 3, or you could jump to 1. If you're on the 3, you could jump to 1, you could jump to the second one, you could jump to 4. So that's how that works. Return the minimum number of jumps needed to reach nums n minus 1, which is the last element of the array. Test cases are generated such that you can reach nums n minus 1. Okay, that's nice. If you want a full walkthrough of this, of the solution, go back and look at the Jump Game. It should be posted, wherever you're looking at this. And I've pasted the solution to Jump Game in here already. The difference between Jump Game and this is that they want to find the minimum number of jumps for this one. For Jump Game, it was a Boolean function, and we only had to return true or false, whether you can get to the last element or you can't. Now this one, they want the minimum number of jumps. So we're going to modify the solution for Jump Game and get this. A couple things you should probably know. These variables, max reach is a variable that we use to contain the largest index that we know that we can get to. And step is how many options do we have from where we currently are. So again, like looking at example 1, if you were at nums 0, step would start out at 2. You have 2 steps that you can take. You could jump to the 3, or you could jump to the 1. If you were here on 3, you have 3 steps that you can take. And we take these steps and we explore what we can do with each of the elements that we can get to. Every time we do that, we decrement step. If step gets to 0, we're out of options and we have to jump. So let's look at this from the beginning. If nums length equals 1, let me look at the constraints here. So yeah, it's nums length is at least 1, Okay, and it's guaranteed that you can solve it. Okay, good. So if nums length equals 1, oh no, we don't want to return true anymore. What we want to return is 0. Because if the length of nums is 1, we don't have to jump at all. The first element is the last element. Next one, if nums 0 is greater than or equal to nums length minus 1, that is, if the contents of nums 0 are big enough that we can just jump to the end from num0, then we will return 1 jump. This one now is going to go away. What we needed to consider before is if nums0 is 0 and the length of the array is greater than 1, we're stuck. We can't get out of num0, so we have to return false. But in this case, that is not going to happen. We need one more variable, and that is we need to keep track of the number of jumps. Initially, we're going to say 1, because we're not starting the index at 0. We're starting the index at 1. So we assume that we've started at nums0 and we've made the first jump to nums1. All right. If let's see, if I equals nums length minus 1, if I equals nums length minus 1, oh, okay, so if we are at the end of the array, then return jumps. We're done. If nums I greater than or equal to nums length minus 1 minus I, well, that means that based on the contents of nums I, we can jump to the end. So in that case, we'll return jumps plus one more jump to get to the end. All right. Calculate max reach decrement the step. If step equals 0, that means we got to jump. We've already explored everything that we can explore from where we are, so we got to jump. Add 1 to the jump. If, well, you know what? They guaranteed that this wouldn't happen. If in the jump game, if we got to an index I that was beyond the maximum index that we could actually reach, well, something had gone wrong and we couldn't proceed from there. That's not going to happen here. All right, and then we reset step. Step is now max reach minus I. It's the maximum index that we know that we can reach minus the index that we are actually on. And if we get all the way through here, well, again, from jump game, if we get all the way through and we didn't get to the end, we got to return false. Now, that's guaranteed not to happen. But I think if we just take it out, it's probably not going to compile because the return statement is missing. But let's try it and see what happens. Run it. Yeah, compile error. Oh, well, so it's a compile error with that. There's no semicolon. Is there anything else? Run it again. Compile error. Incompatible types. Oh, you know what? I pasted this in here and I forgot to change. So we are now returning an int. It's not Boolean anymore. Now what? Compile error. Oh, there. Now we get the missing return statement. So we've got to return something. I don't know. Return. I don't know. -1. It really shouldn't get there. Let's run this and see what happens. Oh, wait a minute. I think I put that in did I put that in the right place? Yeah, I did. It's got to be after. Yeah, okay. So the basic test cases run. Let's try and submit it, see what happens. Later. All right, that's accepted. 2 milliseconds. I'm sorry. Is that milliseconds or microseconds? I don't know. Anyway, it's a good fast algorithm, and it works. So that is it for Jump Game. I peeked ahead. There is no Jump Game 3, so next time we'll do something different. Feel free to like and or subscribe, and see you next time.